So the problem that we're given is that a roller coaster does a loop-the-loop and the circular track has a radius of 8 meters. And the question is asking what speed should the roller coaster have at the top of the loop to make the passengers feel like they are half their normal weight. So you first want to start with just the basic diagram of what's going on to get an understanding of the problem. So you draw what's given, and the given is that the radius is 8 meters, and you want to know the speed when they are at the top of the roller coaster. Then after you draw that, you want to draw your free body diagram. So the normal force is going to be pointing upwards, while gravity is going to be pointing downwards. So we start off with the forces in the y direction. Then you have Fn minus Fg equals ma, and then since this is circular motion, that's 0. So then you have Fn equals Fg, and then in the problem you say that, or the problem says that their weight is half on the top, so then you have Fn equals 1/2 Fg. You have the net forces, the radial direction, which is there, and then since this is circular motion, you have centripetal acceleration, which equals v squared over r. So then you have Fn Fg minus f of n equals m times v squared over r. Plug this into this equation, so then you have f of g minus 1/2 Fg equals m times v squared over r.
So from there, we know that Fg equals mg. So we can substitute that back into the equation that we got. So that makes mg minus 1/2 mg equals m times v squared over r. And then we can factor out the m's on the left side, and that way we can cancel out the m's on both sides. So what you're left with is g minus 1/2 g equals v squared over r, and you can factor out the g, and then if you subtract 1 minus 1/2, you get you'll get g times 1/2 equals v squared over r, and g times 1/2 is the same as g over 2. So from there, then you can just solve for v squared, or solve for v. So you multiply both sides by r, and then finally you take the square root of both sides to get the equation for velocity, and when you plug in the numbers, you'll get 6.26 meters per second.